Thank you. So my name is Sandoche Balakrichenan, and I work at UFNIC. It's the NIC for France, the Network Information Center. So the presentation from me is PKI for IoT using the DNS infrastructure. So in the test implementation that we have done, we had this motivation that whatever we do should be open standards, it should be feasible, and can we solve the problems of the constrained IoT devices and networks. So as you know, 99% of the internet communication, the first thing is the DNS. DNS is the domain name system. So when you type www.afnic.fr, the first thing is that the domain name is converted to an IP address. To get the IP address, you go to the DNS server, and then with the IP address, you connect to the web server, and you do the TLS handshake for encrypted web communication. So in this scenario, we have two governance structures. One is the registry for the DNS, and the other is a certificate authority. So there are two different governance structures in a single communication. So what we are trying to do is that will we be able to use only one governance structure, that is the DNS and its ecosystem, to provide security in IoT? So I'm taking an example. The example is LoRaWAN. LoRaWAN is long-range wide area network. Why did we take LoRaWAN? LoRaWAN is one of the most constrained IoT networks. Here we are talking about data that is communicated in 50 bytes, 100 bytes, etc. So our hypothesis is that if our hypothesis works in LoRaWAN, it should work in all IoT. So that's why we took the LoRaWAN example. So if you see here, we have on the left side the IoT device and the IoT network. That's what we call the RF space, radio frequency space. And from the gateway to the internet, it's the IP space. So there is no constraintness, but in the radio frequency space, there is constraintness. So what normally happens here is that they use symmetric keys. So the keys have to be shared prior to the communication to have encrypted communication end-to-end. So there are two issues. What is the issue? So for example, if you see in the manufacturer end, they create thousands of IoT devices in batches, and they inject these keys, and they give it to the people to distribute. So these keys have to be shared prior to the communication to different stakeholders. So we have operators, distributors, authentication operators, system integrators, et cetera, et cetera. So normally, this key sharing is a big issue. So what currently they do is that either they send these keys via mails, or they stick it behind the devices. So these are all unsecured way of sending these keys. So that's why we wanted to see whether we could do the asymmetric public key infrastructure for this IoT communication. So the issues other than key sharing, what we have here is that the IoT devices are constrained, the network is constrained, there are no availability of CA libraries. We saw in the Vishwas Patel, Dr. Shiva Vishwas Patel presentation, there is a trust store in our web, Firefox, et cetera, that we don't have in the IoT network stack. And another thing is that the certificate authorities comes with a cost. Here in LoRaWAN, we are talking about like 100 rupees per year service. So you cannot have certificates that you buy and use in IoT scenarios. Then what else is that there is a closed security infrastructure, and there are private IoT vendor locked. Scalability is an issue. Bootstrapping trust is an issue. In the web, we have the certificate authorities. Here, you don't have that. So there are multiple issues in IoT. So our objective is to see whether we can use the DNS existing infrastructure. So as I said in the motivation, we are looking at only open internet standards. So we looked at DNSSEC. So DNSSEC, already Dr. Vishwas Patel had given a brief intro. It tries to have security in the first communication that we saw in the first slide, that is the DNS resolution. You have a chain of trust, so you cannot attack or what we say, you cannot overcome this communication by having one server being misused. You have to change all these different servers in this chain of trust. So that's what DNSSEC helps in the DNS resolution. Then the second thing is that DANE also, Dr. Vishwas Patel presented, DANE is DNS authentication of named entities. It is RFC 6698. DANE was developed at the IETF after the problem of DigiNotar. So the issue is that if one rotten apple here, if one certificate authority is compromised, we are able to compromise the complete web communication. So how to reduce this attack surface? So to reduce this attack surface, DANE gives a solution where you can have a fingerprint of the certificate in the DNS, and so that when a web communication happens, when the TLS handshake, you get the digital sign certificate, and you verify the digital sign certificate in the DNS. So that's how DANE reduces the attack surface. So this is how it happens. This is a DANE resource record in the DNS. So the right side, you see this fingerprint, the hash. That is the hash of the digital digitally signed certificate. So when the communication happens and the digital certificate is received by the client, it looks this certificate with the TLSA resource record in the DNS, and validates only with the signed certificate that is in the DNS. So that's how the attack surface is reduced. So we have DNSSEC DANE that enables security in the communication. So the conference is PKI for applications. So how will it be applied in an application scenario? So here we are seeing a roaming scenario, IoT roaming scenario. So this is based upon EduRoam. If you have heard about EduRoam, I'm not sure, but EduRoam is in European universities. What happens is that if you have a login password in one university, you can use the same login password in any other university all over Europe. I think even in the US. I'm not sure if it is there in India. Yeah. So there we use the DNS and the radius protocol to get this secured communication even if you are outside your own campus. So could we do that in IoT? So that was the application that we tried. We presented it at the GIANT network conference. So GIANT is the conference of the education research networks in Europe, and the idea was accepted. So what we do here is that, can we use DNS infrastructure for IoT roaming security? That's what we are trying to apply here. So we had a test infrastructure where we have AFNIC Labs and we have Telecom Sud Paris. It's a university in Paris. So we try to test with them. So what happens here is that AFNIC plays the role of the root CA. It's a certificate authority. It gives the certificates to the different institutions as intermediate certificates. So each institution creates its leaf certificate and it gives to the servers. For example, here you have JS is joint server, NS network server, AS is the application server that is used in the LoRaWAN scenario. So the problem here is that there is a single root CA. So it is a provisioning infrastructure. Then when you try to do the web communication and you are roaming, so what happens is that you have to send a combined certificate. You cannot just send the leaf certificate because the root CA is the only one known. So a combined certificate needs to be sent for establishing a secure communication if you are in a roaming infrastructure. So that is an issue. So how we can use DANE to mitigate this issue? So there is a working group at the IETF called DANS, DNS Authentication of Network Clients Everywhere. So the DANS working group charter is to look at how DANE could be used for communication. Now, where mail communication uses DANE, there are a lot of other things, other networks that use DANE. So how it could be used everywhere. And here, a particular example is how it can be used for mutual authentication. So in mutual authentication, what happens is that you have a TLS handshake. And during the TLS handshake, we can have the DANE indication saying that if you want to validate a certificate, use the domain name that is provided during this mutual authentication. So the client and server can mutually authenticate with the DNS indication. So what we try to solve here is that you don't need a certificate authority and you don't need to pay them. You can use a self-signed certificate and you can add the TLS resource record in the DNS. Thus, the mutually authenticated certificate is validated. We implemented these two drafts that you see in the left, and we presented during the IETF 115 at Vienna. So here what we try to solve is that you don't need to have a single root CA. You can have a federated CAs, and that could be validated. So I'm going fast because of time constraints. So what we have solved is that, I showed you the slide earlier. So we have solved all the issues that is in the green, but the first two issues has not been solved because a PKI certificate is like 2 or 3 kilobytes, and that cannot be sent over the LoRaWAN network. So that's an issue. There are work going on. For example, the previous presenter talked about ad hoc and OSCORE. So elliptical Diffie-Hellman over compression, and there is a working group at the IETF called LAKE, Lightweight Authentication of Key Entities, which is trying to compress the public key digital certificate. And now I think they have come up to 150 bytes. There are other working scenarios like SHIC, static context header compression, where you don't even need to send the data. You have a rule that could evolve these things, but that's all future scenario. So these two issues have not been solved. So the IoT room scenario, we presented at the GIANT conference, and there were a number of universities that were ready to test with us. So we have tested with Telecom Sud Paris, we have tested with Telecom Bretagne, and there are other universities that we will test later. So AFNIC. So AFNIC is the registry for the France. So we have the Network Information Center, and we are into IoT. We are working at IoT for last 10, 12 years. So we started with different French and European funded projects. So we started with provisioning and resolution. Now we are evolving our security and privacy. So we want to use the DNS infrastructure to give provisioning, resolution, security, and privacy. So we had worked with the supply chain industry, which is called the GS1. We were the principal contributor for the GS1 standard, and we are working with the LoRaWAN. LoRaWAN is a consortium of companies which develops the LoRa standard, and I am also the academic working group chair for LoRaWAN. So here we have an idea how the identifier is provisioned. So that's it. I needed to go fast because of time constraints. So if you have any questions.
I have a question.
Yeah.
Isn't it decentralized ID would be a best bet?
DID?
Yeah.
I don't know much about decentralized identifier, but I'm not sure how the governance. Sorry. So if you see here, when I started, I said about the operational feasibility. So we say that we don't want this to work in the next 10 years. We wanted to work it currently. So if you take the IoT identifiers, how will it be governed? How will it be provisioned, allocated, and given to the end user? That I'm not sure. So I cannot give you an authentic answer, but it might work in a research scenario, but in a real-time scenario, how it will work, I'm not sure.
In some sense, that's also a scalable DNS, right? DID.
Okay.
So in some sense, it should work.
It should work.
My feeling is, and it may have advantages in the first two problems. What you said, how much it should be shared, how much need not have to be shared, and then it can create its own identifier. So it becomes somewhat scalable in my opinion, but it needs a further.
So just to answer that, if you see here, you see in the GS1, so they have their own identifier. So it's RFID or barcode.
It can change, that's what I mean.
But yeah, but when we discussed with the GS1 industry, I worked with them for 5 years. So the ideal solution would have been to use IPv6. But I don't think Walmart or Carrefour or Reliance will be changing their shirt tags or anything into IPv6 in the near future. So they want to have their own identifiers. And how do you use their own identifiers and adapt them to the IoT? So if you see here, it is the GS1, it is the RFID or barcode. Here, if the LoRaWAN, there is a different type of identifier. So any type of identifier, and the middle one is the Apple. So we classified them into the flat and hierarchical identifier. So any type of identifier, you could put into the DNS. You don't have to change your existing infrastructure. Yeah, we will. Thank you.
One more question. You have mentioned that there is a constraint in the IoT network, right? That is basically because of the size of the certificate you are talking about. Because of that, you are not able to transmit.
Exactly.
So, is there any provision to go for a data compression and transmit in LoRa divisions, right?
They have done, there are articles which work on compressing the public infrastructure. They're taking out unwanted things, and they have come up to 150 bytes or something. But in addition to that, now IETF is working on there is a LPWAN working group, low power wide area network working group, where they have introduced something called SCHC, SCHC, static context header compression, where you use rules to derive data. In compression and decompression, you actually compress the data and send. Here, you don't even need to send the data. So you just send the rule ID, and based on the rule ID, you derive the data. But I'm not sure whether it will work for cryptographic certificates.
Because there may be a loss in the device informations. So to adding up to this, from CCA, Government of India, we have been initiating one project for the IoT in device certification. Okay. So this, we want to bring all the IoT device into one platform, and CDAC is the initiation. You can just keep in touch with them. So after this discussions, so that could help them to make it towards the LoRa and the network, where we want to integrate in a single network, so that all IoT device talks to only the particular platform.
Okay.
So this will ease off many of the solutions for the device certification in IoT. So that makes more IoT secure device.
Okay.
I hope so.
Yeah.
Thank you.
Thank you.
It's good.
Presenters, and with this the session on PKI for IoT environment concludes. And before we move to the next session, there's an announcement. We are running behind schedule, so I request the attendees to, if they want to have refreshments is served outside. We'll continue with the session, and you can get the refreshments and continue attending the session. Okay, right. I would like to invite Professor Shyam Sundar to honor the session chair, Dr. K.K. Soundarpandian.